If you are watching this video, there is a good chance that somewhere in your home there is a cat, a dog, a bird, or maybe even a more unusual pet. But here is the strange part. Yes, these animals may be our beloved companions, but hidden inside their bodies are living records of millions of years of evolution. Look a little more carefully, and you may begin to notice something extraordinary. Traces left behind by their ancient ancestors. For example, why does your dog have that small claw on the side of its paw that never touches the ground? Why are your cat's whiskers not just ordinary hairs, but more like tiny sensory antennas? Why do the feet of birds look so much like dinosaur feet? And if some snakes seem to have lost their legs completely, why do tiny bumps still remain near the sides of their bodies? And even stranger than that, today we are going on a journey that may make you look at the animals in your home with completely different eyes. Let's begin by taking a closer look at one of our closest companions, dogs. Take your dog's paw in your hand and look carefully at its toes. At the front, you will usually see 4 main toes. These are the toes that touch the ground. They carry the weight of the body while running. They help with balance when the dog suddenly changes direction. But a little higher up on the side of the paw, you may notice something else, a small extra claw. To many people, this structure looks strange. Why is it there? Why does it not touch the ground? Why is it not used like the other toes? This structure is usually called a dewclaw. In some dogs, it can still be partly useful. For example, it may help when the dog turns quickly, moves across steep ground, or grips an object. But in many dogs, this structure is not as active as the main toes. In some dogs, it almost looks like a small leftover piece attached to the skin. And this is where we need to understand something very important. Just because a structure is vestigial does not mean it is completely useless. This is one of the most misunderstood ideas in evolution. A vestigial structure means this: a body part that once had a more important or more obvious function in ancestors, but over time became smaller, changed, lost part of its role, or shifted toward a different function. So, vestigial does not mean trash. For example, in humans, the appendix is not a completely meaningless organ. It has some roles connected to the immune system and gut bacteria. But compared with the larger digestive system linked to the plant-based diet of our ancestors, its function today is much more limited. In the same way, the dewclaw in dogs can still be useful in certain situations. But that does not change what it represents: an evolutionary trace of an older toe arrangement. Now, let's talk about birds. Maybe you keep a budgie, a canary, a cockatiel. Maybe there are chickens, ducks, or geese out in the yard. Whatever the bird is, take a closer look at its feet. Scaly skin, long, thin toes, hard, curved claws. And if you look just a little closer, you will notice something strange. These feet do not feel entirely modern. They look like they belong to something much older, something ancient. Because birds are not merely relatives of the dinosaurs. They are dinosaurs. The surviving branch of the dinosaur family tree. When we hear the word dinosaur, we usually imagine enormous jaws, thick tails, and terrifying teeth. But evolution rarely moves in a straight line. Many dinosaur lineages disappeared. They died out. But one group survived, small, feathered, light-bodied, and over millions of years. That surviving lineage changed. It became the sparrows on your windowsill, the canaries singing in your home, the chickens walking through the yard. So when you look at a chicken, you are not just looking at an ordinary farm animal. You are looking at an inheritance from the deep past, a living dinosaur legacy. Of course, today's birds are not identical to the dinosaurs of old. 66 million years is a very long time. Bones became lighter, Teeth disappeared, front limbs became wings, bodies grew smaller, and feathers took on completely new roles. But the traces are still there, in the feet, in the claws, in the bones, in the way they lay their eggs, even in the way they walk. The history did not vanish. It is still there, hidden in plain sight. Now, let's turn to cats. Sometimes the word strange doesn't quite cover it. They stare at blank walls. They sprint through the house at 3 in the morning. They settle with great seriousness into a box that is clearly far too small for them. But one of a cat's most remarkable features is its whiskers. These aren't ordinary hairs. Scientifically, they're called vibrissae, specialized sensory hairs. When your cat moves through the dark, squeezes through a narrow gap, senses an object approaching, it's reading the information those whiskers send back. Their roots are richly wired with nerves, so a cat doesn't only see the world with its eyes, it reads it through this exquisitely sensitive system on its face. And here's the more interesting part. Whiskers aren't unique to cats. Mice, seals, dogs, even some marine mammals depend on them, which tells us something. Whiskers are part of a very old sensory system, inherited from the shared ancestry of mammals. In us humans, that system is far weaker. We have hairs on our faces, but nothing like a cat's whiskers. So, your cat's whiskers aren't just a cute detail. They're an ancient inheritance from the deep history of mammals. Cats carry other traces too. Take their claws. Your cat's claws don't stay out all the time. Normally, they're retracted, pulled in. They come out only when the cat hunts, climbs, or defends itself. This is tied directly to the hunting past of the cat family. Sheathed claws stay sharp, and deployed at exactly the right moment, they give a huge advantage when seizing prey. So even those little paws shredding your couch are a household version of a hunting anatomy. Millions of years in the making. Now, let's move to a more unusual pet, the snake. Everyone knows snakes as legless animals, but the real story is far more interesting. Snakes evolved from 4-limbed reptile ancestors. Over time, their bodies lengthened, their legs shrank, and in many lineages the legs vanished from view entirely. And yet, in some snakes, the past is still visible. In certain species, pythons and boas especially, there are small projections near the rear of the body. These are called pelvic spurs. At first glance, they might look like a little claw or a hardened bump, but anatomically, they're connected to the remnants of ancient hind leg and pelvic structures. So, that tiny projection on a snake's body whispers something to you. My ancestors once had legs. That's a powerful evolutionary trace, and it isn't limited to the animals alive today. The fossil record preserves early snake forms, still carrying the remnants of hind legs. Fossils that show the loss of legs didn't happen all at once, but gradually, step by step. And this is one of the most beautiful things about evolution. Nature rarely erases the old parts in a single stroke. Sometimes it shrinks them, sometimes it changes them, sometimes it adapts them for a new role, and sometimes it simply leaves them behind. As a trace, let's return to birds. But this time, let's talk about flight. Look at a bird, see a wing, and you'll automatically think, for flying. But not every wing is for flight. A penguin's wings aren't built for the air. They work like flippers, driving it through the water. In ostriches, emus, and kiwis, the wings have largely lost the power of flight altogether, and this tells us something important. A structure's origin and its present-day job can be two completely different things. The wing may have first been linked to flight, but as different lineages adapted to new worlds, That same structure could shift to a new purpose or lose its old one entirely. For the penguin, the wing is no longer a tool of the sky, but of the sea. For the kiwi, it has shrunk into an evolutionary memory, almost invisible. So in nature, saying this organ is only good for one thing is usually misleading. Evolution takes whatever material is already on hand and reshapes it to fit new conditions. Now, let's talk about the third eye. I know, that sounds like fantasy, but what we mean here isn't some mystical mind's eye. In certain reptiles and amphibians, there's a small light-sensitive structure on the top of the head. It's called the parietal eye, or the pineal eye. This structure doesn't form images, the way our ordinary eyes do. The animal doesn't see its surroundings with it, the way we see with ours. But it can detect changes in light, and that can be linked to daily rhythms, hormone balance, even body temperature. In some lizards, this structure is quite prominent. In other animals, it has faded over evolutionary time or shifted to something else. Humans don't have a visible third eye like this, but deep in our brains, we carry the pineal gland, and our biological rhythms are still tied to the cycles of light and dark. So the third eye isn't the magical organ of popular culture, but seen through the lens of evolution, it's a genuinely fascinating inheritance, an ancient way of sensing light. And there's another structure, tiny but remarkable, right in your own eyes. Lean toward a mirror. Look at the inner corner of your eye, the part nearest your nose. You'll see a small pink fold there. This fold is regarded as one of the remnant structures, associated with the third eyelid found in other animals. In birds, reptiles, cats, and dogs, this third eyelid can be far more developed, sweeping across the eye like a thin curtain, protecting it and keeping it moist at the same time. In us, it's much smaller. It lingers in the corner of the eye like a faint trace. And this is exactly how evolution works. Sometimes it leaves its mark on massive bones, sometimes on a single small claw, sometimes in a bird's foot, sometimes in a tiny bump along a snake's body, and sometimes in the corner of your own eye, in a detail you never noticed while looking in the mirror. That's why evolution isn't something found only in laboratories, in fossil halls, or in thick biology textbooks. Sometimes it's in the paw of the dog sleeping in your home. Sometimes it's in the whiskers of the cat on your couch. Sometimes it's in the feet of the bird singing in its cage. And sometimes it's right there, in your own body. In today's video, I've traced evolution through the animals in our own homes. Of course, if we opened the door to the wild, the list would grow almost endlessly. Flightless birds, legless lizards, cave fish, blinded eyes, and so many more. Nature never fully erases its past. Look carefully, and you can still read the traces of old stories written in the bodies of the living things around you, because sometimes evolution carries a fish onto land, and sometimes it sends a land mammal back into the ocean. If you enjoyed these kinds of stories, don't forget to subscribe and tell me in the comments which animals past you'd most like to uncover. Together, we'll keep exploring nature's strangest, most surprising stories of evolution. Stay curious.